Hello everyone, so let's continue about this 5.2 operations on the vectors. Okay, section A, additions. We'll continue to talk about additions. Okay, class activity 2. Okay, so in this class activity 2, so basically we have to discuss two examples. Okay, we have two examples. The first one, let's draw a diagram. Okay, so basically in this diagram, so we are going to be showing this number, the first one. Okay, first one. Okay, so in this diagrams we show a helicopter. Okay, the helicopter is moving from A to B, flew from A to B along the vector A, B, and then from B, and then flew all the way to C. Okay, so basically the first one. Okay, so describes A, B plus B, C in a single vector. Okay, this is quite straightforward, right? So basically we have we can apply the triangle law. So straight away we can find out AB and BC, they have the single vector as AC, right? So this is very straightforward, right? So basically we can draw these diagrams. Okay, so we can get an answer. We can get an answer. This is all the way through here. Okay, look at AC, right? Okay, next one, B. Okay, so describe the overall movement of this helicopter. The helicopter from A to B and B to C, right? This helicopter move, right? So second one is overall movement. Overall movement of this helicopter. Of this helicopter by single vectors. Okay, so basically it's the same thing. Okay, by single vector, the vector is A, C, right? Because they move this way, it's there, this way. Okay, then C. See what's that? So what is the relationship between the result A and B? So the result of A and B is that, okay, if we have these two translations from A, okay, let's say this is the helicopter, they move to here, and then this translation from A to B and B translation to C. So we can see the example is that, okay, this is called overall movement, or sometimes we call that overall translation. Okay. And then we can use a single vector as A and C, right? So this is the thing we have learned from this the first example. Okay. Now let's look at the second one. Second one, golf ball flies along this path. Let's draw the diagram first. So basically we have all the diagrams and the Q and P, right? So it's going from this way. Okay. Right. So in this example, so basically a golf is flying this direction, and then it has when the golf is flying. When it's flying, so basically he have a vertical velocity, and same time they also have horizontal velocity. So basically we're going to find out that number A is draw a vector to describe the sum of these two vectors. So basically a golf is a flies when he flies along, so it has two velocity. One is the velocity in the horizontal is Vx, the other one is Vy, so in the vertical and horizontal. So let's find out the sum of these two. Okay, so we need to find out Vx plus Vy. So again, we have a vertical velocity, whereas horizontal velocity. So in this case, we can apply which law? We will apply the parallelogram law, right? So in this case, we can draw the sum. We can transfer this line. In fact, when we use the parallelogram law, so basically we just draw in this along this way, right? So what we're going to do, we just transfer this line to here to make it more clear, right? So assume this is another cube. Okay. So what's the result? So basically we're going to have this line, because these two are equal, right? These two are equal, right? So basically we can draw in this way. Alright? So here we use the parallelogram law. Then we find out. So this is the O to Q bracket Q, right? So we have these two. Alright? Okay? So this is a single vector to have this. Then look at the B. Describe vector of the, okay, so basically, okay, so when we have these two vertical and horizontal velocity, so we have a sum of these two velocity. We give a name of this. We call that is a effective. So basically V plus we call it effective velocity. So this is the name we call it. So okay, you can call them the sum of these two velocity. You also can call them as a different resultant of these two velocities. Basically, we give the name is called effective velocity. In the first example, so basically we call this one, we call overall translations, right? All we have a different names, right? Okay. So from here, and then we have a summary. We're gonna summarize this too. So when sum of these two vectors, u and vectors, and sum of two vectors, we call it sum of two vectors. So we give it a name called it resultant vector. Okay, we call it resultant vectors of these two sums. Okay, so for examples, okay, here we got some examples, right? Just now we'll talk about some examples. So examples, the first one is when we have these translations from point A to B and translation from B to C. So we have this, we call it overall this resultant vector. Resultant vector calls the overall translations, right? And the other one is the velocity. Velocity, we call them this sum of these two velocity put up together, we call it effective. So that is the resultant is effective vectors. So when we have these two, so we can see that let's write it. resultant, the resultant factor is called resultant factor, right? So this is the resultant vector. Okay, so in this case, this is also a resultant vector. Okay, so in this case, the resultant vectors is the in terms of translation. So this called it overall translation. Okay, well these two vectors we call it effective translations. Okay, sorry for that. Effective velocity. Okay, and okay, when we have two forces, when we have a first, okay, for example, we have a first. So first is acting on this one of the body. Maybe assume we have this is the one of the objects. So we have two firsts. One is going up. One is this. Sorry. So for examples, we have one object. So one first is going in this direction. We call that is the first horizontal, and we have the other one is going down. So we have first vertically down. So we have these two first, but these two first we represent them as a vector. So we have a combined, we have a sum of these two vectors. We call it, use the parallelogram law. So we have this sum. We call it the resultant vector, right? Resultant vectors. So in this case, we call it resultant first. Resultant first. So this is all the examples, right? So first one first of all, we talk about the translations. First one we talk about the translations. Second thing we talk about this velocity, and the other one is we talk about the first. If we have two first, we also have a combined a sum of these two vectors. Okay. Okay. Now let's give an example of this. Okay, let's talk about example 9. Okay, in this example 9, so basically we have two firsts. Okay, so basically let's draw an example for this example 9. Sorry, need to draw this thing properly. It's easy. Okay, so we have O, and then we have this direction. So we call it A, we call it B. Okay, so basically we have two. And also take note that angle is 60 degrees. Okay, so okay, in this example 9, so we have two firsts. Okay, we know two firsts, OA and OB. Okay, so basically they are at the BOA equals to 60. So they are working on one object. Okay, this object. So they're working on one object. So basically have these two directions. Okay, two different verses. So basically, so this here is 12 Newton, and then here is what 8 Newton. Okay, so two first are working on these items. Okay, or this object. So basically, let's find out. So let's draw. Okay, magnitude of this OA equals to 12 Newton, and OB equals to 8 Newton. Okay, so basically we have two. Okay, let's find out. So what's the question? The question is to find out the magnitude of this resultant first. Find out the resultant first. So what is the resultant first? Okay, so basically resultant first of this, right? Just now in the activity 2, we already discussed what is resultant first. Resultant first is the two vectors, the sum of these two vectors. Sum of two vectors. Okay, which means we can draw here resultant first equals to the OA plus OB, right? So okay, this is the sum of these two vectors. Okay, let's look at this thing. So before that, so let's construct. Okay, look at this one. OA, OB. These two plus these two is what? So OA plus OB. So basically we'll use the parallelogram law, right? So in this case, let's draw a parallelogram. So let's move to here. Sorry. Okay. Let's see, right? So in this case, what is the resultant? What's the resultant first? Okay, resultant. So we will say that. So we connect these two. Right? So in this case, we use the parallelogram law. We immediately can find out OC. The OC is the resultant force of these two vector sum. Okay? So in this case, so this is we use the parallelogram law, right? Okay. So and then I find out. So now we need to find out what is magnitude. What's the magnitude of this OC? So the question is OC. So how much? This is the thing we can find out, right? So in this case, we have the first one. We're in the triangle OAC. In the triangle OAC, so basically, okay, let's look at this one, OAC, right? So we have this, we already know this AC equals to OB, right? Right? These two are same, right? So what's the answer? So this is also 8 Newton, right? Okay, because parallelogram law, parallelogram. And then we also know that, okay, we also know that is a let's look at how this. We also know this BOA equals to 60, right? So from here we can find out, because this is 60, right? So then we can find out their angle. Okay, OAC equals to 180 degree minus 60 degree. So this is how much? This is how much? This is 120 degree, right? Okay. It's because because we use the this is the triangle. This is parallelogram law. So from here we use this because this is the. Let's look at this. Okay. Because in this we will have this OA parallel to OC, right? Okay, this is very straightforward, right? Okay, now let's look at OC. So how to find out OC? In this case, okay, so now here is very important concept, right? We're going to use a very important concept for this. Okay, in this in one of the triangle, let's look at here. Let's recall the cosine rules. Cosine rules. Okay, so what is cosine rules? Cosine rules, if you have a triangle, this is C, this is B, this is A, right? So how do you find out A? A equals to B squared plus C squared minus 2AB cosine what? The triangle A, right? So this one, right? So we call it cosine law, cosine rules, right? So here we also use the cosine rule. Cosine rule. So how we use this cosine rule? Cosine rule is in this case, right? To find out this AC. In this case, the OC. In this case, OC square equals to what? OC square equals to the OA square plus AC square minus 2 times OA times AC times cosine OAC, right? So because this is all magnitude, okay? So and times this OAC, right? So in this case, we can bring in them. So in this case, so OC squared equals to OA. So what is OA? OA is here, right? So it's a 12 squared plus AC. So what's AC? AC we already know, right? AC is here. So is AC equals to OB, and OB is here. So A squared minus 2 times 12 times A times cosine OAC. So what's OAC? OAC just bring 120 degrees. So from here, then we can work out. Use the calculator. We can actually work out OC equals to 304 newtons, right? Sorry, Newton. Okay. Right? So, and we can continue work out this. Okay, so they can also equals to 17.4 newtons. So we can 0.4 newtons, right? So therefore, so what's the result? So what's the result? The result is OA plus OB. So OA plus OB. So AC, right? So that the resultant first is OC, right? Right? Being have the answer 17.4 Newton. Right? Okay, so in this case, the magnitude of the resultant first. So we can continue right here. It's OC, right? So from here we can work out this is the answer. Okay. Okay, so that's all. Okay, when we go back, let's try the example 9. Try example 9. Okay, try yourself whether you can find out the correct answer. Okay, that's all for today. Thank you very much. Bye bye.